Hi everybody, I'm Joey. I'm from Google, and I'm the team lead for Shaka Player. Today I'm going to talk to you about Shaka Streamer. If you are already familiar with some of the Shaka products like Shaka Player and Packager, you may not have heard of Shaka Streamer yet because it's pretty new. So first, what the hell is it? This is a tool that simplifies content prep. In particular, we handle VOD and Live, Dash and HLS, and we do all this by wrapping up FFmpeg and Shaka Packager so that you don't have to mess with them. It's all based on config files, and we currently support Linux and Mac. Everything that works on Linux today also works on Mac. This requires Python and external copies of FFmpeg and Packager. It's all distributed on GitHub. Shaka Streamer today. And warning, we just heard about OTT at scale. This is not to scale. This runs on a single machine. You cannot use it to run your whole production infrastructure today. So it's new. We don't know who's using it. Your name here, please let us know. We're using it ourselves to generate Shaka Player demo content, including a live stream that we're running 24/7 today with VP9 hardware encoding. We've had 164 installations in our first month, which was pretty exciting, especially compared to the number of GitHub clones we had in the same time frame. So people seem to like that we're using PyPy to send this out. And no pull requests so far, but we hope to double that soon. So please let us know if you'd like to contribute. So why did we build this thing? Some of you may have had some experience with FFmpeg and similar tools in the past. So if you have, you probably know what's coming. This is what it takes to encode 1080p content in 2 different codecs on FFmpeg. And this is as simplified as I could possibly make these command lines. So 230 incomprehensible words. This is not something you want to type. It's barely something you want to write a shell script for. And that is just encoding the video. Add to that the Shaka Packager commands that you have to type to actually produce MPD and HLS output. And this is just MPD for the record here. So after all that typing, you would finally have some 1080p Dash content. Or you could type that. So for my money, having config files for my different assets, my different encoding profiles is way more maintainable than having separate scripts and separate tools for all these different conditions. So let's take a look at what these config files look like. Over here on the left, you see the input config. This is extremely simple. We want 2 different inputs, the video stream and the audio stream, both from the same file. There's a lot more you can specify there, but we do our best to auto-detect everything and have defaults for everything. So in particular, we'll figure out the frame rate, we'll figure out the resolution, all the characteristics of those static inputs. And on the right, you have the pipeline config. So this tells you that we're doing VOD content as opposed to live, what codecs and resolutions we want, and this will create the command lines for FFmpeg. It'll run FFmpeg and Shaka Packager. It'll connect everything through through named pipes, so you don't even have temp files to clean up afterward. And if you wanted to change this from 1080p to 4K, add 4K. And if your input is only 1080p, we will politely ignore your suggestion because we're not going to upscale anything. So what this means is that if you have a particular profile for what you're going to do with your VOD assets, the resolutions and codecs you're going to use, you can reuse that pipeline config no matter what resolution the original asset was in. And we will intelligently ignore the resolutions that are higher than the input. Same goes for audio channels. If you give us stereo, we're not going to somehow change that into surround sound for you. And if you wanted to encrypt that, just tell us to encrypt it. By default, this is going to go to Widevine's UAT server, and it's going to use test credentials, but you can easily tell us what license server to contact, what credentials to use, and all of that is part of the config file. And finally, if you want to push all that output to cloud storage, you can just give us a cloud storage URL on the command line. We support both Google Cloud Storage and Amazon S3. So, additional options. We have support for hardware encoding. You can set all the various dash parameters and encryption parameters you could possibly want. If you know something about FFmpeg and you're comfortable doing this, you can actually add your own FFmpeg filters, just arbitrary FFmpeg filters. We can also do live streams, either from looping a particular static file or set of static files and making a simulated live stream. We can also take input from webcams or any arbitrary command. In particular, we have a live stream on the Shaka Player demo that is a visualization of the Git repository's history, and that is using this arbitrary command input of Shaka Streamer to run the open source tool called Gorse. Output locally to cloud storage or Amazon S3, and then this can be used either as a command line app or a Python module. What's missing is Windows support, because we have not managed to get FFmpeg to talk to a Windows named pipe yet. We're missing network inputs, which will be relatively easy to add when we do. We are missing AV1, AC3, and EC3 codec support have all been requested. Multiple GPU encoding on Linux is not yet supported, but that's fairly simple to add considering that FFmpeg does support it. Raw key encryption, where you can specify your own keys and your own PSSHs, that's coming as well. Someone requested that we make a simple way to overlay a logo rather than having to do custom filters in FFmpeg for that. Configurable output format so that you could say, I want VP9 in MP4, or I want it in WebM, or I want my H.264 in TS for my HLS streams. And finally, it might be nice for some people if we gave you an easy way to have a static binary of Packager and FFmpeg, or even a Docker container, so you don't have to install those things externally. So, any questions? No?
So, what is the default encryption mode if you don't have that?
Question is, what is the default encryption mode? The answer is CTR mode. However, you can easily change that in your pipeline config. Let me go back. Right here where it says encryption enable true, you can also add another field there that specifies the encryption mode to either be CTR or CBCS. Any other questions? Yes? Question is, can you do multiple audio tracks and languages and captions? Yes, you can do multiple audio tracks in multiple languages. The language can be auto-detected if the metadata is in the original source file, and if it's not, you can specify. Anything you specify overrides whatever might have been auto-detected in the file. The same is true with captions. You can have multiple caption tracks. Currently, we're only supporting VTT, but we're working to improve that. You specify the languages for those as well. Another thing worth mentioning is we currently don't have a good way to do captions on live streams. So unfortunately, there's just no, at least we have not yet discovered the sane input format that is a continuous live stream of captions. So if you have any insights on that, we would love to hear it. Zach.
What's the protocol for the DRM system? Is it secrets?
Question is, what is the protocol for the DRM system? The answer is we are using Shaka Packager to handle all of the encryption, and I believe what it does is it talks to a Widevine license server, or it allows you to specify the keys explicitly. So what we have in our config file right now is you can specify what that server is and what credentials to use. You can specify content ID. If you don't specify content ID, we generate one randomly. And I believe that's it. We'll be adding raw key encryption, which is the packager terminology for you to specify your own keys and PSSHs, at which point you could do multi-DRM if you want to manage the key exchange yourself. I believe CPIC support is coming to Shaka Packager, but I would have to check with the Packager team lead for details. Yes? Question is, are we using libav or FFmpeg binary? We are using the command line front end for FFmpeg. I suppose you might be able to do the same thing with libav's command line front end, but In particular, we're testing and directly supporting FFmpeg. And specifically, we're testing with the binaries that are available in the latest versions of Debian and Ubuntu. What we do at runtime is check the version of FFmpeg that you have, wherever it came from, and we require version 4.1 or greater at the moment. That's because of some bug fixes that were introduced in that version that we needed for particular things we're doing. Yes?
So you mentioned auto detection on the inputs for things like frame rate and so on. I assume that's based on metadata as well. And if so, are those overridable?
The question is, auto detection for frame rate and other input characteristics, is that based on metadata and can it be overridden? Yes and yes. We actually call ffprobe and parse the output to determine what those things are. Frame rate in particular we use to calculate the GOP size, and then based on the segment size, which you don't see here in this slide, it defaults to 4 seconds. But you can change the segment size, and we will multiply that by the frame rate to set the GOP size in the encoder. Yes? Question is for live output or input? For output, we don't support RTSP. In particular, we targeted Dash and HLS from the beginning. So we've never had a goal to be an RTSP encoder. We do have a feature request open to take RTSP and RTMP as input, and that will be really easy to add because FFmpeg already supports those as input channels. But no, we have no plans to do RTMP or RTSP output. I think if you were going to do that, you could probably do that with FFmpeg without any kind of Dash or HLS packager.
So extensibility to other codecs that you have to consider roadmap. I know that, for example, XHE ABC is that part of the plan?
So extensibility for other codecs and what is planned. Right now, we have an immediate AV1. That is, I already have a change in progress for that isn't quite working yet. Not sure why yet. We have a feature request on GitHub as well for AC3 and EC3 support. As far as extensibility goes, there is a third config file that you don't see here that is completely optional that allows you to set the bit rates and define what the resolutions are and define what bit rates are used for each resolution for each supported codec. And so extending for more codecs means adding to those defaults. Oh, wake up. Adding to those defaults and then defining any codec-specific parameters that have to be passed to FFmpeg. And so there would be one file where you would go and define the bit rates for that codec, and another file where you would go and add whatever FFmpeg commands are necessary. So it's relatively straightforward, and as soon as we get AV1 working, that commit will be a good reference for how to add new codec support. We don't have any other codecs open feature requests or plans right now other than those 3. But I would expect that AV1 support is going to be part of our 1.0 release. And time permitting, AC3 and EC3 would be in that release as well. Other codecs, if you are interested, please file a feature request on GitHub.
The reason I asked specifically about XHE and ABC is because it's supported in Android 8 as well as in iOS 13. So there's a lot of people moving in that direction to use that audio codec because of its loudness, support for loudness, metadata, as well as for its kind of cellular friendliness. It's a bandwidth for audio.
Okay, and tell me again the exact name of that codec.
Oh, XHE.
XHE-AAC, okay.
It's the next generation of the family.
And it's twice as many letters, so it's got to be twice as good, right? No, I wasn't familiar with that codec. It sounds like a good idea. Right now, we support AAC and Opus, and Opus default bit rates are about half of the AAC default bit rates for the same channel count. And Yeah, I would be very open to adding support for those things. One thing that we're going to have to deal with as we start adding more and more codecs is the ability not only to check FFmpeg's version to say this is a thing we can support, but that if you're asking to encode Opus, that you have a version of FFmpeg that has Opus support built in, and EC3 and AC3 and all these other codecs. So right now, because it's a pretty small set, and at least most binary packages have everything we're using, we haven't had to get into that yet. But as the codec world starts to grow and open up, we're going to have to do a little more detailed feature check. So, yes? The motivation to create the streamer. Well, there were two different internal tools that we were using for VOD and live, and they both sucked. And every time we would run into somebody either elsewhere at Google, elsewhere at Widevine, or outside of the company who was having these same problems of, creating content is a pain in the butt, and why isn't there just one button I can press to create some content that I need to test my whatever it is I'm testing? And we were certainly in that boat, and we had developed some tools that were hitting some percentage of the goals of this project, but neither of them 100%. In particular, we had one relatively organized tool in Python that only worked for VOD and could not be retrofitted for live. And we had a totally different tool written in Bash that only worked for live and was nearly unmaintainable. And certain piece of the pipeline would fall over and the rest would not notice. And so finally we built one thing that's organized, that does both, that's robust, that serves all of those use cases, and decided to open source it so that other people could benefit as well. Yeah. How long did it take to get to where we are now? Let's see. I wrote the first commit in June, and it's now October. Throughout July and August, and I forget exactly when they left, but throughout July and August, we had, through mid-September, we had 2 interns working on it, and they worked on it through the middle of September, and then we, up through and including our open source launch, all of the code was most of the code was written by our interns, Vicky and Preston. Hi, Vicky. Hi, Preston. And yeah, so big shout out to them for all their hard work. And then since then, we've committed quite a bit more to it, and getting things out into PyPy and adding features and polish and things. So, yes, Andy.
I don't get it. It's open source. Anyone could put a phony nose and glasses on it if they want. So what prevents somebody from adding ingest interface 1 onto the nose of this?
So what is to prevent someone from adding new input sources to an open source project?
Specifically ingest interface 1.
Sure. I don't know what ingest interface 1 is, but
Unified streaming John Simmons thing.
sure. So in any case, the answer is what's to prevent someone from adding features to an open source project? Nothing. By design, we want people to contribute. We want people to add features, and if those features are radically out of line with our plans, then you can keep it in a fork. It's Apache license. You can do whatever you like with that. And if you want to coordinate with us and get things back upstream, we would love to have that conversation.